Hi everyone. Tonight we're going to discuss the time value of money. The time value of money stands for the idea that a dollar today is not the same as a dollar tomorrow. In fact, a dollar today is worth more than a dollar tomorrow. Why is that? Well, think of it this way. First, it's worth more today because of inflation. As we've discussed, inflation decreases the value of money over time. As a result, a dollar today has more buying power than a dollar in a year's time. Thought of another way, that $3.97 Starbucks latte is going to cost you around $4.25 a year from now, given current rates of inflation. Same drink, same size, same ingredients, just more expensive. Another way to think of the time value of money is that if I have a dollar today, I can do what I want with it. I can spend it or save it. If I spend it, I get what I want today. If I save it, I can earn interest on that dollar. Saving it is like loaning it to a bank. They pay me interest. Conversely, if I have to borrow money, then I have to pay interest. The time value of money has two important applications. First, it helps us understand how much something will really cost us if we have to borrow money to get it. To figure this out, we use the following two formulas. PV stands for present value, the value of a dollar today. FV stands for future value, the value of a dollar at some point in the future. R stands for the annual interest rate. Let's use an example. Mr. Gold wants to jump higher, so he goes online and finds the Jacob Hiller Jump Manual. It costs $67, but he doesn't have $67. Mr. Paget does and says he'll loan him $67 for a year, but he'll charge him 10% interest. Mr. Gold wonders how much that will end up costing him. Well, the future value formula lets us determine this amount. We know present value, $67, and we know the interest rate, 10%. So plugging those both into the formula yields a future value of $73.70. So Mr. Gold's $67 jumping manual will end up costing him $73.70 after he ends up paying Mr. Paget back the $67 loan plus 10% in annual interest. The first thing present value let us do was evaluate what borrowed money will cost. The other thing it lets us do is consider the value of money paid to us in the future. So let's take an example. Grube's father works for Qdoba and wants to buy the secret recipe for the Diablo burrito. Mr. Klein also wants the recipe. Mr. Grube offers $900 today, and Mr. Klein offers you $1,000 a year from now. Which should you take? Well, in order to decide, you need to be able to compare the offers in terms of today's dollars. Mr. Grube's is already in terms of today's dollars, but Mr. Klein is offering you $1,000 in 1 year. Let's assume the prevailing interest rate is 10%. Mr. Klein is offering $1,000 a year from now, so we need to use the present value formula to bring those dollars back to today. Using that formula, it yields a value of $909. So Mr. Grube is offering $900. The present value of Mr. Klein's offer is $909. Now, Mr. Grube, realizing the value of the Diablo burrito formula, counters with an offer of $1,200 2 years from now. You can use the same formula, again assuming a 10% interest rate, use that same formula with one modification. 2 years is essentially 1 plus R times 1 plus R. So raise the 1 plus R to the number of years, in this case 2. If it were 20 years, you could use the same calculation, just with a 20 instead of a 2. Using the 2 in this case yields a present value of $991 for Mr. Grube's offer. So the present value of Mr. Grube's offer now is $991. Present value of Mr. Klein's offer is $909. Present value lets us evaluate different options in terms of today's dollars. Net present value takes this one step further and considers projects that offer combinations of benefits and costs, some today and some in the future. Think of benefits as cash we receive and costs as cash we pay. Look at projects A, B, and C on this chart. All have different combinations of benefits and costs at different points in time. How should we evaluate this? Again, by getting all of the benefits and costs in today's dollars. So let's go through this point by point. Project A has a combination of dollars realized today and dollars realized 1 year from today. A is 100 realized today and 0 realized a year from today. So the present value formula, because it's all today's dollars, really is simply $100. So the net present value given an interest rate of 10% is $100. Project B, on the other hand, has a combination of dollars realized today and dollars realized a year from today. So we need to get those all in today's value. Well, today it's going to cost me $10 to start this project. So there's $10 in my present value formula calculations. A year from today, I'll get $115. So I need to take that $115 and convert it into today's dollars using the present value formula. If I take negative 10 plus $115 divided by 1 plus R, I get $94.55. Project C has a combination as well, $119. Today I get in benefit, positive, versus the cost, is shown by a negative here in B. And a year from now, I'm actually going to have a cost of $20. So using the present value formula, 119 minus, again here because it's a cost, minus $20 in present value gets me a value of $100.82. Now, again, the best project to undertake is the one with the highest net present value. Using those calculations, the highest net present value is Project C. Could be a little bit deceiving because if you didn't actually reduce this to the present value, you'd get a smaller number. But doing so gives you $100.82. One last thing for today. The book used a 2006 example of the Powerball lottery. I decided to look at today's. Today they're offering $380 million or $256.8 million. The difference, the 380, is over 30 years with the first payment this year. And the 256.8 is paying it all out to you today. Well, I decided to try to back into what the interest rate would be. In doing that, I simply looked at 256.8 times 1 plus R to the 30 equals 380. That's simply our present value formula. Switched it around a little bit, and I got an interest rate of 1.47 or around 5%. Now, for my money, the stock market over time has paid out about 7% per year. For my money, I'd probably take it all today and see if I could do better. All right, that's it. Have a great night, and I'll see you in class soon.